Okay, so welcome to Probability and Statistics. Here's the problem we're going to be going over. It's an example of Bayes' theorem. So if you want to just go ahead and read this, this is the important information that you'll need to know and I'll be using. So just pause the video and read that real quick, and I'm going to dive right into it here. Okay, so for this problem, looking back at the problem, you're going to go ahead and we're going to fraudulent users. We're going to have F is equal to a fraudulent user. And we're going to have T denote a user is equal to a user who makes a call in 2 or more places outside of the city in a day. Alright, so what we're looking for is if the same user originates calls from 2 or more metropolitan areas in a single day, what is the probability that the user is fraudulent? So the probability of being fraudulent given that the user made 2 or more calls. Given that there's 2 more calls. Alright, so this is going to be a Bayes' theorem problem. And Bayes' theorem laid out for this problem is going to be the probability of 2 or more calls given fraudulent times the probability of being fraudulent. We have both of these, and I'll actually lay this out a little bit more. But 2 or more calls being fraudulent, we can see from the problem a little earlier, and you can go back to the video to see that. But that will actually be equal to 0.3. So fraudulent users originate calls from 2 or more areas. So 2 or more areas given fraudulent is equal to 30. And then the probability of fraudulent is the proportion of fraudulent users, which is 0.01, or 0.01%, so 0.0001. And I'll write this all out for you. But then moving into the bottom using Bayes' theorem, you basically take all the conditions and add them up. So the probability of 2 or more calls giving fraudulent times the probability of being fraudulent, so the repeat of this, plus the probability of 2 or more calls given not fraudulent times the probability of being not fraudulent. So in Bayes' theorem, when you use the extended format like this, all the values in the bottom have to be mutually exclusive and exhaustive events, so that there can't be any overlap between them. So in order to have no overlap, you have to just do the opposite of these two variables. So you have the fraudulent users and the non-fraudulent users. Those are completely exhaustive of the sample matrix, because those are the only 2 types of people you can have. So going ahead and solving this out, the probability of 2 or more areas giving fraudulent is equal to 30%. And then the probability of being fraudulent is 0.1234. Oh, sorry, just 1, 2, 3. That's a 1 right there. Over the probability true false, which is equal to 30 times 0.001 plus the probability of true of 2 or more spots given not false is equal to, oh sorry, I overwrote. Got ahead of myself. Or behind myself, I suppose. 0.01, because this is the percentage of people who make legitimate calls in 2 or more areas. And then times 0.9999, because this is the opposite of what's left of 1 minus this. I'll mess that one up too. That's 3 zeros right there. That's 3 zeros up there. And then if you just solve that out, then you'll find out that the probability of of someone being fraudulent, given they made 2 or more calls outside of the area, is equal to 0.003. F given T. And that's pretty good news for the phone companies. So that's how you use Bayes' theorem. Is you just take all the events and close them out in order to get probability of T basically down here on the bottom. If you have an F right here, then you need an F naught over here, more or less.